Okay, so today we're going to talk about properties of radicals. So the first thing is that if you're multiplying a radical and it has the same root, that's the same thing as nth root of A times nth root of B. Okay, so the index is n and the radicand is A, and here the radicand is B. If you're taking the nth root of a fraction, that's the same thing as nth root of A divided by nth root of B. And notice this only works if the index is the same. So let's start looking at simplifying some problems here. Now you guys should remember back to like middle school and maybe like algebra 1 that you can just do a square root of a radical. All right, so we're doing a factor tree here. So I'm going to factor tree 147. And 147, let's see here, 147, let's try 3. So 147 is 3 times 49, and then I know 49 is 7 times 7. Now I stop when I get to prime numbers, so this is prime, prime, and prime. So now I know that the square root of 147 is the same thing as the square root of 3 times 7 times 7. And you guys should remember that when you're taking a square root, you're looking for two numbers that are multiplied together to equal that number. So for example, I have 7 times 7 here, a group of 2. Well, 7 times 7 is 49. And what's the square root of 49? Well, square root of 49 is 7. So out comes 1, 7. So I find 2 under the radical and 1 comes outside. So that means this equals 7 square root of 3. The 3 stays underneath. And that would be my answer here. Okay? Let's try this one. So square root of 64 divided by 7. Well, I know 64 is not divisible by 7, so I'm going to use my quotient property. And I'm going to split this up into square root 64 over square root 7. I know that the square root of 64 is 8 divided by square root 7. And so I'm going to rationalize my denominator here because you can't leave radicals in the bottom. So to rationalize your denominator, you need to multiply the numerator and the denominator by whatever will make the bottom a perfect square. So for example here, I need one more 7 to complete that 7 times 7 group. So I need a square root of 7 on top and a square root of 7 in the bottom. So this becomes 8 root 7 in the numerator, and square root of 7 times square root of 7 is just like square root of 49, which is just 7. Square root of 7 times square root of 7 is just 7. So this becomes 8 square root 7 over 7. And that's your final answer. So going back to the beginning, I used my quotient property. I split these in two. I knew square root of 64 was 8. I'm going to multiply the top and bottom. This is my clever form of 1 by square root of 7 over square root of 7. That way I complete this group on the bottom. Notice I'm taking the square root, so I'm looking for groups of two numbers together. So I needed another 7. Square root of 7 times square root of 7 is just 7 in the denominator, and then 8 square root of 7 in the numerator. Let's look at a couple more examples here. All right, 3 times square root 15. So I'm going to factor tree the square root 15 first. And 15 is just 3 times 5. I can't go any further. So that means they're both square roots, so I can combine them together using my product property. I have a 3 here, a 3 here, and a 5 here. So that means this is square root of 3 times 3 times 5. Now remember, we're taking the square root, so I'm looking for groups of two numbers together. So there's 2 3's. 3 times 3 is 9, and the square root of 9 is 3. So out comes a 3, and those 2 3's inside go away. So this ends up equaling 3 square root of 5. And that's my final answer there. Okay, let's come over to this guy. So this equals, and so we're doing the cube root on this one. I'm going to make this a little bigger, it's easier to see. Okay, so I've got cube root of 2 over 9 times 3 cube root of 4. So I'm going to start with this fraction here, and I'm going to split that into cube root of 2 over cube root of 9 times 3 cube root of 4. Now, I know that 4 is 2 times 2. That's my prime factorization of 4. And I know that 9 is 3 times 3. That's my prime factorization of 9. So I'm going to go ahead and write this out. So my 3 here, this 3, is my coefficient. I'm going to bring that to the front just to kind of organize it a little better. Now, I have this 2 under the radical in the numerator and these other 2's over here and here. So under my radical, and remember it's a cube root, I have 2 times 2 times 2. I have 3 2's. And in the denominator, I have cube root of 3 times 3. So I have a group of 3 2's in the numerator. Notice I'm taking the cube root this time. So I'm looking for groups of 3 numbers together. And 2 times 2 times 2 is 8. And the cube root of 8 is 2. So I know that this is going to go away. And this is going to come out a 2. Now there's already a 3 in front. And I just took another 2 out. We're multiplying here. So that becomes a coefficient of 6. So I end up with 6 out front. There's nothing left in this radical in the numerator, and I just have 3 times 3 in the denominator. Now to rationalize this denominator, notice we're doing a cube root, not a square root. So I need one more 3 in order to make this a group of 3 in the denominator. So I have to multiply the numerator by cube root of 3 over cube root of 3. I'm missing one more 3. So in the numerator, this becomes 6 cube root 3. And in the denominator, this becomes cube root of 3 times 3 times 3. Well, what's the cube root of 3 times 3 times 3? Just 3, because I have a group of 3 numbers together. So this becomes 6 cube root 3 all over 3. And I can go one step further to simplify this. 6 divided by 3 is 2. So it becomes 2 cube root 3. And that's your final answer on that problem. So to go back to the beginning, just to reiterate what we did. So this 3 came out front, this guy here. I knew that 4 was 2 times 2, so I put them all together using the quotient property, so 2 times 2 times 2. I knew the cube root of 2 times 2 times 2 is just 2, so that comes out and multiplies with the 3 that's already there. And in the denominator, I have cube root of 3 times 3. So I'm right here. I need to finish that group of cube roots on the bottom, so I need one more cube root of 3 to make it a group of 3. And I get 6 cube root 3 over 3, which simplifies to be 2 cube root 3. Okay. A couple more examples here. And keep in mind that if you're understanding, you can go ahead and move on to the homework. So, I have 12 over square root 5a. Now there's nothing I can simplify. 5's already prime. I have this variable. And I need to complete this group under here to make it a square root. So to do square roots, you need groups of 2 numbers together. So I need an extra 5 and an extra a. So I'm going to multiply by square root 5a over square root 5a. And that's going to give me 12 square root 5a in the numerator. In the denominator, I'm going to have 5 times a times a. So since we're doing square roots, I'm looking for groups of 2. So I have 2 5's and 2 a's. Well, 5 times 5 is 25, and the square root of 25 is 5, so out comes a 5. A times a is a squared, and the square root of a squared is a, so out comes an a. So in the numerator, I have 12 square root 5a. In the denominator, I had 5a. And nothing cancels, so that's it. Our denominator is rationalized. We don't have any square roots in the denominator. All right, 2 more examples here. 18m cubed, square root of that. So I'm going to make my factor tree. So 18, when I factor tree it, see here, that's 9 times 2, 3 times 3. Here are my primes. So that means that square root of 18 is really just square root of 2 times 3 times 3 times m times m times m, because it's m cubed. Now we're doing square roots. We're looking for groups of 2 together. So I've got 2 3s and 2 m's. So out comes 1 3, out comes 1 m. Then we get 3m on the outside, and square root of 2m is left inside. And that's it. All right, this one's a little bit trickier. We have to factor first. So this becomes square root of 4 times a squared plus b squared. And using my product property, I know that's just square root of 4 times square root of a squared plus b squared. And what's the square root of 4? Well, it's 2. And this part can't factor anymore because it's a sum of squares and not a difference of squares. So it stays the same, and that's your final answer. And I think that's it. Oh, one more. So, okay, so the numerator and denominator here, I'm going to split them up. So it becomes square root 45x over square root 32y to the 4th. And I'm going to do my factor tree for 45. So 45 is 9 times 5. 9 is 3 times 3. So here's your prime factorization for the numerator. So the numerator becomes square root of 3 times 3 times 5 times x. And your denominator, so 32 is 8 times 4, which is 4 times 2. I'm running out of room. 2 times 2, and 4 is 2 times 2. So I got a lot of primes here. 2, 2, 2, 2, 2. So that means my denominator is square root of 2 times 2 times 2 times 2 times 2, 5 of them. And then times 4y's. 1, 2, 3, 4. So when you do square root, you're looking for 2 numbers. So we have a pair of two 3's here. I've got a pair of 2's, a pair of 2's, a pair of y's, a pair of y's. So out comes a 3, out comes a 2, out comes another 2, a y, and a y. So we're left with 3 on the outside, square root 5x in the numerator. 1, 2, 2 2's in the denominator. 2 times 2 is 4. And then y times y is y squared. And I'm left with square root 2. Now we have to rationalize the denominator. So you don't want a radical in the denominator. So I need to multiply the numerator and denominator by another square root 2 to complete that group of 2's there. So this becomes 3 square root 10x. Notice this is under a radical, and so is the 2's, you can multiply them. And this becomes 4y squared times square root 4. Well, square root 4 is just 2. So your final answer is 3 square root 10x over 8y squared. Done.